Hello, and welcome to Hispanic Heritage Month. This week for our science lesson, we'll be focusing on STEAM, and I'm your host and science lab teacher, Miss Ricketts. And our STEAM week will be featuring science, technology, engineering, art, and math. For our show today, we'll be focusing on magnetism and review of magnetism and different applications. We'll be looking at magnetic fields. We'll be looking at scientific process skills and the way scientists conduct experiments with its power in the process, art and magnets, maze engineering, and coding unplugged. And if there's time, we'll talk about the uses of magnets in everyday life with a special feature on Hispanic Heritage Month with Latino scientists. Good morning, my scientists. Miss Ricketts here, and welcome to my laboratory. It's a wonderful morning this morning, and we have a special episode this week for science. It's our STEAM week. Oh yeah, that's right, I said STEAM. Things are getting steamy in here. Well, you know, STEAM stands for science, technology, engineering, art, and math. And that's what we're going to be focusing our lens through. Everything is through STEAM today. We're going to be, of course, reviewing force and motion and magnetism with the power in the process and our process skills. We're going to be doing art and magnets, engineering and magnets, and coding unplugged. So I'm really excited for this episode and what we're going to be doing today. So let's get started. Fantastic. Now, we've been talking about force and motion, and how many of you remember what a force is? Okay, good. I heard you. That's great. Remember, a force is a push or a pull. Let's do that again. A force is a push or a pull. One more time. A force is a push or a pull. Excellent. And we talked about 3 different types of forces. So let's review. We talked about friction, and if you're quiet, you can hear it. You can actually hear the resistance, them pulling against each other. Friction, our first force. Our second force, I have a ball here. If I release this ball, what do you think is going to happen? Is it going to float to the sky? Is it going to stay where it is? Or is it going to be pulled down? Well, you already know. Watch, I'm going to release it. It was pulled down. Let's do it one more time. You see, gravity is what pulls it down. Our second force, gravity. Excellent. And now our third force, magnetism. I have 2 magnets here. Here we go. They love each other. Magnetism. And that's where our focus is today. The force of magnetism. I have my little Han Solo, Mr. Potato Head friend here again today, and I'm wearing my Princess Leia apron. So let's do a little review on magnetism. Can you see my magnets here? Fantastic. Let's review. We know that magnetism is a force. It's a push or a pull. And that magnets have poles. We have the North Pole here and the South Pole here. And the poles are where the magnetic force or field is at its strongest. Remember, we did an investigation where opposite poles, look, do this, attract, come together. And we did an investigation where same poles or similar poles push away from each other or repel. Remember our motions? Attract, come together, repel, push apart. Attract, come together, repel, push apart. I said
Attract, come together, repel, push apart.
Oh yeah, you remember our total physical response to the dance that we did. Fantastic. And the one more thing that we did last time is that we went fishing. Fishing with magnets. Remember, magnets are iron detectors. Magnets love iron. So anything that has magnets and iron in it, look what happens. Obviously, the paper clips have iron in them. So magnets love iron. So what we're gonna do today is take those skills, our knowledge, and bump it up a level. Everyone say, bump it up.
Bump it up.
Bump it up.
Bump it up.
And apply what we've learned about magnets. Good. First of all, you could tell that there's a magnetic field. I'm gonna put my paper clips here. And right now, I could tell that the field's not too strong. The closer I get, the closer I get, the closer I get, what's gonna happen? Oh! It attracts. That's where the field was very strong. We're going to be talking about magnetic fields today, and there's power in the process. So let's take a break and we'll be right back. Process skills. There is power in the process. How scientists conduct experiments. Now we're back, my scientists, and we're going to get ready with our process skills. There's power in the process. Can I get an amen?
Amen.
There's power in the process.
Amen.
And so our process skills, we're looking at how scientists conduct experiments. So you could take these same skills and put them with different subjects, whether it's magnetism or relative density or something with land and water. But today we're going to focus our process skills and experimental design and how it relates to magnetism. So the first thing you need for an experimental design process skill question is a testable question. A what? A testable question. That's what are you trying to find out? What question are you asking? What are we testing? And here is our testable question for today. Does the state of matter, where we have a solid, two liquids, and a gas, affect the strength of the magnetic field? What? Here it is one more time. I'll say it a little slower. Does the state of matter, solid, sand, liquid, oil and water, or gas, air, affect the strength of the magnetic fields? That is our testable question for today. So let's go over the procedure, our steps that we're going to do to conduct the experiment. We have our sand. It's pink. I know, scientists like pink too. We have oil, a liquid. We have water, a liquid. And we have this one. You think there's anything in here? There is. I'll open it up. You ready?
We're ready.
Oh, yeah. Oh, I felt it. One more time. Yes, there's air in here. There's air in here. Remember, a gas takes up the whole space of its container. You might not be able to see it, but I can feel it. So here we have our substances. 4 substances, 3 states of matter. Then we're going to have our containers of paper clips. Now I put the same amount of paper clips in each container. The same amount of paper clips in each container. I'm going to pour the same amount of substance in each container. the same amount in each container. I'm going to use the same magnet for each container. Now, how are we going to measure it? Well, let me show you. Let me move this to the side. After I fill this up with sand, I'm going to see how strong the magnetic field is by taking the magnet and pulling it up through the substance to see how many paper clips it will pull through the state of matter. Let me say that again. I will fill this with the substance, put the magnet right here so it can have that magnetic field, and see how many paper clips can be raised through the substance.
So, Miss Ricketts, why are you going to do this?
Because I want to test the strength of the magnetic field through each of the substances and each state of matter. Let's go back to our testable question. Does the state of matter, the substance, affect the strength of our magnetic field?
Got it.
You sure? We can ask again. Does this, everyone repeat after me, does the strength?
Does the strength?
I'm sorry, I messed up. Does the state of matter?
Does the state of matter
affect
the
strength of the magnetic field?
Of the magnetic field.
Awesome. That was great. I love it when we do a call and a response type of thing. I know you're answering because I can hear you. Great. So before we actually do it, scientists like to think. They like to make what we call a hypothesis. Hypothesis? Yes, a hypothesis. What do you think will happen before we do the experiment? What do you think will happen before we do the experiment? So let's take a pause and think about it. You know the question. Does the state of a matter affect the strength of the magnetic field? You know the procedure. I showed you how we're going to do it. What do you think will happen? Which substance, which state of matter will pull through the most paper clips? Would it be the sand? Would it come in first place and pull the most paper clips? Would it be oil? Would it be water? Or would it be air? Let's take that time to think. Which substance or which state of matter will attract the most paper clips through it? Take a moment and think. I'm going to give you some thinking time. Thinking time. Hypothesis. What do you think will happen? And we're back. Let's see what you came up with. And we'll vote by doing a thumbs up. You ready? Okay. How many of you chose the solid pink sand as the one that when I put the magnet close to, more paper clips will come up through this one? Let me count. Thumbs up, remember. 1, 2, 3. Oh, that's two. Oh, okay, I see. Interesting. Thumbs down. Now, let's do oil. How many of you chose the oil that when I put the magnet next to it, it's going to pull up the most paper clips? Thumbs, don't. No, you're going to vote once. Good job. Okay. Let's go to the water, a liquid. How many of you said that when I put the water in here and raise it up, raise the magnet up, it's going to pull up the most paper clips? Thumbs? Good. Okay. Now, last one. How many of you chose the gas, air, as the one that when I put it in there, it's going to pull up the most paper clips? Thumbs? Some of you voted twice. No fair. Only vote once. Okay, good job. Excellent. Okay, I got my tally. I think I got everyone. Now let's bump it up a notch. Just a little bit. You ready? I want you to justify your answer. It's not good enough you just say, oh, this one. The gas. The oil. The water. Why? You've got to tell me why. Why did you pick the sand as a state of matter, which when we put the magnet next to it, it's going to pull it up? Why the oil? Why the water? Why the gas? You ready? Do you need a stem? I think that the sand will pull up the most paper clips when I put the magnet next to it, because I think when I pour the oil in the paper clips and have the magnet run against it, I think that the oil will have the most paper clips, because do that for each one of those now and get back to me. I'll give you some think time. Justify your answer. Give evidence as to why you selected your substance as the one that will pull through or attract the most paper clips. Now we've come to the part in experimental design where scientists record their data. So I've made this particular data chart so we could put our data in. So let's take a look at it. Over here, we have the state of matter: air, water, oil, sand, gas, liquid, solid. And then we have on this one our trials of the number of paper clips pulled through the substance. T1, T2, T3, the total and average. T1, T2, T3, what does that mean? You know, scientists, we like to repeat things. We conduct repeated trials, multiple trials. We do experiments over and over again. Why? So that we can get good, clean data. We can get data that's verifiable, that's accurate, that's reliable. And the way scientists do this is by doing it over and over and over and over again. 3 is just what we're going to do today, but scientists do it several times. Then we take the total and the average. Remember, it's all about the relationship between the state of matter and the number of paper clips pulled through that state of matter. Now, I've made this myself, but my job is to help you make it. So let's do a little science notebooking. Here I have my science notebook, and I'm going to turn it horizontally, or not portrait, but landscape. And I always start with my first relationship, state of matter. Draw my line down. Good across. Now I know I have air, which is my gas. I know I have water, which is my liquid. I know I have oil, which is also a liquid. And I have sand, which is a solid. And I'm looking at the relationship between that and the number of paper clips pulled through. That particular state of matter. Remember, scientists like to conduct repeated trials. T1, trial 1. T2, trial 2, T3, trial 3, get a total, add them all up, and then get an average, which is you're adding them all up, which is your total, and you're dividing it by the number of trials, which is 3. So we could take a look at it. Now, you've made your own little relationship between the state of matter and the number of paper clips, and it pulls through to test the magnetic field, the strength of magnetic field. Got it? Good. And we're back. So here we have our 4 containers of paperclip. Everything is the same. My 4 containers of my state of matter, same amount. Again, what's the one thing that I'm changing? Take a minute. The one thing that I'm changing is the state of matter. Everything else is constant, it stays the same. So we made our predictions, we know our procedures, let's get started. Let's start with air first. No, that's oilless. Let's start with the air first. Here it is. Remember, there's something in here. Let me pour it in. Uh-oh, did I spill any? Okay, I think I got it all. Okay, good. Ready? Let's see. Let it feel. How many to pull up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. 18 the first go around from my air. So I put 18 here. Trial 1. Let's try it again. In the back, everything's got to be the same. Same procedure, same way, same thing. Here we go. Ready? Here we go, same way. Let's count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 this go around. Here we go. Let's try it again. Same procedure, same way, same thing. Here we go. Pull them off. Let's see how many we have. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16.
And your helper's saying you had 15 because one was still there from last time.
Uh-oh. So it's just 15? Okay. I'm glad all scientists need help. Thank you. So here we go. Now, let's do the same procedure with our water. Let's do water next. This is it. Ready? Here we go. Pouring the same amount of water that I did air. Here we go. Right here to this rung. Now the reason why I'm using recycled materials is because I have sustainability and we like to save our planet, but I know at home you don't have the same materials that you would have in the science lab. So you're going to use household materials. You're going to use what you already have. And science is all around us. So you don't need quote unquote special lab equipment. You have this container. It has different lines in it. Use those lines to count. Here we go. Are we ready? Ready, my assistant? Here we go. Pull it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, 19. Interesting. Put it all back. That was more than the air. Didn't count on that. Put a paper towel right here. Maybe you can see it better. 19. Let's write that down. Ready? Again, trial 2. Same procedure, same everything. Here we go. Pull it off. Can you see it better on the paper towel? More of a contrast? Let me open it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 again, huh? One more time, trial 3. Everything the same. Put it in. Just like we did. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Interesting. Boy, my predictions were a little off, but that's fine. Look how many things that we have when we're totaling it for water opposed to compared to air. Very interesting. How we doing? Let's go. Let's keep on going. This is exciting. I'm having fun. Ready for oil?
Yes.
I am. Here we go. We're gonna pour the oil in. Same amount, same rich, same line. Ooh. Right there. Same line, household materials. And this is why I got these bottles, because they have lines in them. And most water bottles do have lines in them. Ooh, I'm excited. Let's see. Okay. Let me get it all together. Here we go. Nice and oily and greasy. Ready? Have paper towels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let me get my paper towel. 17, right? Trial 1. Let's record. Let's do it again. Wipe it off. Trial 2. Here we go. Make sure they don't hide from me. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19? Wow. My goodness. Let's try it again. Am I seeing that much of a difference? Last time, trial 3. Let's go. Hey, bub. Here we go. One, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Interesting, 10. I'm gonna have to add them all up and average. We'll do that in a minute, but we have one more substance to get through first. Put them all together. Let's do and test the sand. Ooh, here we go. This one's oil. Let's get a new paper towel. Clean up, clean up, clean up. I'll put this right here in my little set. I want to get a fresh paper towel. It's my hand paper towel. Here we go. Ready? Sand. Same amount of paper clips. Same amount of sand, different substance. But one thing we're changing, that state of matter. Pour it, pour it, pour it, pour it. Now there are a couple of paper clips that came out because I tried it before. So I'm gonna take those out. So it's the same. Make sure I don't cheat, okay? Everything's gotta be the same. Ready? Let's go. Ready? In there? Okay, good. Ready? Let's go. Is this working? 0 the first time. Let's try that again. Ready? Maybe I'm doing it too fast. 0 the second time. Wait a minute, I don't like this. Let's try it again. Zero. Well, we're going to take some time to look at our data and figure out what's going on here. We'll be back. And we are back. We've recorded our data, my scientists. So let's take a look, see if we can find some trends, see if we can analyze it, and see what we have, okay? So we have air, it picked up 16 paper clips. Water picked up 18 paper clips on average around. Oil, 15 paper clips, and of course, sand right here had 0. So let's rank them. It'd be first place water, second place air, third place oil, and last place sand. Now when I made my prediction, these two were right. I figured that because the weight, there's so much mass and weight pulling down on the paper clips, it would be harder and we would have more resistance. So I figured these two, they're heavy. But in my prediction, I had air before water. That air would have more paper clips attracted to the magnet than water, but that's not what happened. Water first, then air. So that kind of confused me because I thought that there was more weight on the paper clips in water than air, and it would be harder for the magnets to come up, for the paper clips, I should say, to come up and go through. So when sometimes the data doesn't match your hypothesis, what you predicted, a good scientist, the process they will go through is conduct more trials. Keep on going and see if you get the same trends. See if the same type of thing happens. 5 times, 6 times, 7 times, 8 times, 9 times, 10 times to see what kind of data you get. Now, if the data stays the same, the next thing you do is you do a little research. Conduct a little research between the oil and water. Find out the differences between the two to see if it can explain why the water came in the first place having more paper clips versus the air. It doesn't always match what you predict, but it's all about the power of the process. Got it? Good, thumbs up. Now to the next segment. Steam Week Part 2. Steam Week, Engineering a Maze and Coding Unplugged. And we're back. Remember, this episode is about steam. We're getting steamy in here. So we're gonna do the engineering part. We are going to engineer a maze. Well, what does that have to do with magnetism? Let me show you. We did an experiment about which substance, solid, liquid, or gas, can a magnetic field go through. And the sand, not so much, but just to show you that it can go through a solid, I have paper here, a solid, I have a magnet on top. Look, it can go through a solid. So let's just establish that first. I'm gonna put this to the side for right now. Let's talk about creating our maze for Mr. Potato Head. Here we go. What I did first, I didn't have any graph paper at home. And I know I want you to use household everyday items. I don't want you to go out and buy anything special. And I took a ruler, and you could see I just made plain lines going down and going across to create my grid. Plain lines. In fact, some of them aren't straight, some of them are a little crooked. You could tell Miss Ricketts made this one. Then I went to my computer and I saw a simple template for a maze, and I took my marker and I just outlined it. Just that easy. No special equipment. But I bumped it up a notch. I took my hot glue gun, and you don't have to use a hot glue. You can use regular Elmer's glue, but I use my hot glue gun. And if you do, have an adult with you. And some straws, and cut it to the lines of my maze. Got it? Good. Just that easy. Let me put this to the side. So I just glue the straws here. Put this to the side. So here I have my maze, and I'm starting here and I'm ending here. What you're going to do is you're going to take a little magnet, and I have a little magnet right here, and go through to the end of the maze using a magnet. So here's my magnet here. Here's my trusty green magnet. Let's see if I can do it. Here we go. Kind of upside down. Got it. And he's out. Any questions? Very simple engineering. But let's take it up a notch and do a little coding unplugged. Coding unplugged? Let me show you. I have my friend Herbie here. Let me turn him on. Herbie's my robot. Oh, I'm sorry. Hi Herbie, how are you doing today? Oh, he talked back to me. Okay. You doing well? It's a beautiful day. Are you glad to be back in school? Me too. Herbie is programmable. What does that mean? It means I can tell Herbie where to go and how to do it. So here it is. Herbie has commands, and these are Herbie's commands. On Herbie's back, you'll see arrows and commands. He has the forward arrow, the right turn arrow, the backward arrow, and the left turn arrow. So we're going to stick with these 4 commands today. So what I could do, I could tell Herbie to go forward. Go. And he goes forward. I can tell Herbie, turn right. He turns right. I can tell Herbie to go backwards. Arrow. He goes backwards. I could tell Herbie to turn left. Use a left command. But I know not all of you have Herbies at home. So we're going to take our maze that we just engineered and our command cards to see if we can code Herbie through the maze. So get your pencil and paper and write down the code that you hear me and see me do with our little Herbie. Now I put a little bead on that so you can know that that's the head, that's Herbie's head. Okay, so I still have the magnet. I'm gonna put my command cards here so you can see them. Now I know on TV, right and left may be a little bit different, but that's okay. We'll still get through it. You ready?
We're ready.
Are you sure?
Beep, beep.
Good. So let's go over our procedure one more time. We have our commands, forward, backward, right turn, left turn, just like you see on Herbie. And we're gonna number them right here and write them down. So this is for, the first command is forward. The second command, this is what it looks like. So you're gonna draw little arrows, little command arrows at each step. We got that?
Got it.
If you got it, say beep, beep like Herbie.
Beep, beep.
Okay, here we go. Here we go. Start writing. Now, write it down and say it as I do it. Here we go. Forward 1.
Forward 1.
Turn right.
Turn right.
Forward 1.
Forward 1.
Turn left.
Turn left.
Forward 1.
Forward 1.
Turn left.
Turn left.
Forward 2.
Forward 2.
Turn right.
Turn right.
Forward 1, 2, 3, 4, 5, 6. Forward 6.
Forward 6.
Turn right.
Turn right.
Forward 1, 2, 3, 4. Forward 4.
Forward 4.
Turn left.
Turn left.
Forward 1.
Forward 1.
And Herbie is out. Beep, beep. I didn't hear you. Beep, beep.
Beep, beep.
Now we're going to check our code to make sure. I have the code here. I wrote it down. And we're going to make sure and double check and triple check to make sure it's right. Here we go. Forward. First line, forward 1. Turn. Right. Forward 1. Turn left. Forward 1. Turn left. Forward 2. That leaves us right here. Ready? Turn right. That's line 8. Line 9, forward 6. Did it. Line 10, turn right. Line 11, forward 4. Line 12, turn left. And line 13, forward 1. We did it. We got the steps. Beep, 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 beep. Good. We just did Coding Unplugged. Yay! You're my engineers and my coders. Go, tiny coders, go! STEAM Week, Art and Magnetism. Hello, we're back. I'm glad you liked that little short commercial break. And now we're coming out to the pure art segment in our show today, Art and Magnets. So let me give you a little heads up of what it looks like. Here's a picture that we did the other day. Here's a small picture. I'll be putting these on eBay, so please bid on them. You'll love it. And you're gonna see how we use science and art and how they go together. Now, we discussed earlier about magnetic fields, right? And how magnetic fields can go through matter. For example, if I have a paper clip and I have it on this piece of paper, I can put my magnet and make it look like I'm doing magic. But how can I do it and make art? Well, let me show you. I have some paint here. Put a little paint here. My assistant, could you give me some black paint, please? Thank you. And you can see me putting paint on the paper. Ooh, a little messy, but that's okay. Let me just wipe it up. Let me get a paper towel, wipe it up on here. Wipe my hands. I like to work clean. Some blue, and that's why I wear an apron, because accidents do happen. Some red, white, blue, and pink. I like pink. Then I'm going to take materials that I know are magnetic, like paper clips. Remember, we know, and we discussed earlier, that paper clips have iron in them. And I'm going to generate a magnetic field. So I'm going to take my magnet, come underneath my tray, and start moving them and making a design. And swirling my colors together. You see the paper clips moving. Trying to pick up some pink there. Try to pick up some blue. We've got some red. Go over here. Make a figure 8. Getting all the colors together. Oh, yes. I think it needs some more blue. Then, I can take these up and I can try something new. Let's try a new shape. I'm going to use a bunch of magnets together. Here I have some circular magnets together. I'm going to drop them in and see what kind of pretty design I can make with that. I can do it up and down. Ooh, it's really going. Or I can do it sideways. Let's see what it looks like if I do it sideways. No, it keeps wanting to go up and down. Interesting. Okay, I want to put some more blue in there. It needs more blue. Let's see, I have some clips now. Let me take these off here and have these binder clips, they call them. And let's see if they're magnetic. They are. Let's see what kind of pretty designs I can make with this. Hold it up so you can see it. Move it around. Move it around. Pick up some of that red. Oh, this is really abstract. I think I see a bus in here. You see a bus? If you squint real hard, you can see a bus. Oh, okay. Maybe not? Okay. I can see it. And a little more pink. Brighten it up a little bit. Here we go. And let me add a ring and some clips and see what happens. Oh, beautiful. Nice, beautiful swirls. See how it's moving? Oh yeah, my masterpiece is just about done. Some more swirls. I think it's done. Let me take all my elements, my magnetic materials off. And I'm gonna let it dry. Here's some of the ones we did earlier. Beautiful. Magnetic art. The world is your art studio. Have fun. I hope you enjoyed your time with us today at this episode when we did STEAM, science, technology, engineering, art, and math. Have a good day, and remember, you can use whatever you have around the house. The world is your laboratory. Bye-bye.